Hi, and welcome to the AWS IIoT Edge Workshop video tutorial. My name is Simon Panic. I'm a Partner Solutions Architect on the Scale Center of Excellence team. During this tutorial, we'll be walking step by step through the workshop. For those of you who do not need step-by-step guidance, feel free to refer back to this as you need as you work through the workshop in a self-paced manner. Before moving into the workshop itself, I'm going to spend some time covering a number of the AWS services that you will encounter throughout the workshop. As we move through these different services, they're going to come in the order that roughly matches that of the workshop. The first service we'll encounter is AWS CloudFormation. This is a service that allows us to build infrastructure as code. Throughout this workshop, we'll be using CloudFormation to deploy a number of the resources and infrastructure that are required at the beginning of the workshop. For those of you performing this workshop at an AWS provided event, this will actually be done for you by Workshop Studio. For those of you performing this on your own, you'll walk through the steps of deploying this CloudFormation template to create your infrastructure. Now, what exactly is infrastructure by code? What it is a means of creating the infrastructure within our AWS account and defining it through code in terms of either YAML or JSON. A developer on their local workstation or on a cloud IDE like Cloud9 will develop a template using JSON or YAML and then store it either locally or in an S3 bucket. From there, it can be uploaded to the AWS CloudFormation console and use it to create a stack. These stacks are a collection of resources that can be deployed throughout the AWS account or across multiple AWS accounts. There are a number of benefits to using CloudFormation. One, this means that we can easily reuse resources that we've already created. It also means we're going to be much more consistent. If we created a resource in a particular format or configuration, we know that we can replicate that again simply by rerunning that template. And secondly, it also improves security because we know that we've addressed security issues with a primary resource application. We know that if we have defined it through this template, we can rerun that template and know that those security issues will also be addressed in these new resources. The next service we'll encounter is AWS Systems Manager, which is a powerful service with a breadth of features and capabilities. We've categorized these features into operations management, applications management, change management, and node management. Operations management features work in concert with other AWS services, leveraging automation to help bring visibility to and automate resolution of any issues. Under applications management, features help you manage and operate your application resources in a context relevant to your applications, teams, resources, and structures. Under change management, the features help you reduce business impact and risk by helping you schedule, validate, and improve and automate changes to your cloud, on-premise, and edge resources. And finally, under node management, features give operators the tools they need to perform day-to-day activities to maintain your environment. The features we'll be using today during the workshop are Sessions Manager and Run Command, and we'll discuss these in a little more detail throughout the workshop. AWS Systems Manager has a number of primary benefits. 5 of them are listed here. The first being the ability to shorten the time to detect problems. AWS Systems Manager helps you quickly view operational data for groups of resources, so you quickly identify any issues that might impact applications that use those groups. Second, it allows for easy automation. AWS Systems Manager enables you to automate operational tasks to help you make your teams more efficient. Third, you're able to improve visibility and control, which helps you easily understand and control the current state of your resource groups. Fourth, you're able to manage multi-cloud and hybrid environments. You can manage servers running on AWS, other clouds, and in your on-premise data centers through a single interface. And fifth, you're able to maintain security and compliance. AWS Systems Manager helps maintain security and compliance by scanning your instances against your patch configuration and custom policies. After AWS Systems Manager, we'll be introduced to AWS IoT Greengrass. This is the first of multiple AWS IoT services that we'll be using throughout this workshop. AWS IoT Greengrass is an Internet of Things cloud service and open source edge runtime that helps customers develop, deploy, and manage IoT device software. AWS IoT Greengrass has multiple ways it can be used to build IoT devices and device software. As you can see here, there are 2 primary deployment methods. The first being on devices that directly connect to the AWS cloud. These could be, as you can see in the picture here, IoT-enabled cameras, consumer devices, industrial equipment, vehicles, any of the devices that actually have the capability to connect directly to the AWS cloud using AWS IoT Greengrass. The second deployment method is through a hub or an edge gateway. This is for devices that don't have a direct connection to the AWS cloud. It allows it to act as the bridge between the AWS cloud and the IoT device in the field. This is the format that we'll be using in today's workshop. AWS IoT Greengrass has a number of edge capabilities, which makes it ideal for controlling IoT devices in the field. You're able to perform local messaging, data and state sync, lifecycle management, machine learning inference, stream management, as well as secrets management, all locally. This means that these services and features are available at the local device, even if connectivity to the AWS cloud is not always available. In today's workshop, we'll be touching on a few of these. We'll be using data and state sync to monitor our actual equipment functionality in the field. We'll be using lifecycle management to push some updates to the different Greengrass components that are on the device, as well as stream management for, again, the data being pushed from the devices to the measurements on the assets created in AWS IoT SiteWise, which we'll discuss later. Greengrass also has a number of management capabilities. These include remote fleet management, remote app management, over-the-air updates, security, local tools, and local resource access. Again, we'll be touching on a few of these during the workshop. We'll be doing remote fleet management, as well as over-the-air updates. And of course, security will be a top priority in our implementation today. After installing AWS IoT Greengrass on our edge device, we'll be introduced to AWS CloudWatch. In this case, CloudWatch will be used to store the logs from Greengrass within AWS Cloud. AWS CloudWatch allows you complete visibility into your cloud resources and applications. It also allows you to collect, monitor, act, and analyze on that data. You're able to collect metrics and logs from your AWS resources, applications, and other services that run on AWS. You're able to monitor and visualize the different metrics coming in from these applications. You can set reactions to specific events so that you can automate responses. And you have the ability to analyze these metrics and perform more informed decision-making based upon that data. Another important management tool is the AWS Identity and Access Management, or IAM, service. It is a web service that helps you securely control access to AWS resources. Specifically, it lets you control at a very granular level who can perform what actions in your account under what circumstances. A few things to point out on this list of features is the granular permissions, so you really are able to control at a very detailed level who can perform what actions. This is a free service to use, and it's integrated into many other AWS services. During the workshop, we'll be using AWS IAM to create and update a number of policies and roles so that different services and users within the workshop are able to perform specific actions. We'll be using Amazon Elastic Compute Cloud, or EC2, to act as the edge gateway during our workshop. EC2 are virtual servers that reside in the AWS cloud. They're incredibly flexible, and they allow you to scale up or scale down very quickly. The EC2 instances are the actual compute instances that you can use in your cloud account to perform computation. Here we see a diagram of a high level of what these EC2 instances are. We have physical servers located in AWS global regions and availability zones. Each one of these servers has a host server that resides upon it along with a hypervisor. And the hypervisor is going to split up these compute resources into logically isolated compute use for each user. We have over 700 current types of instance types, some of which are general purpose, and some of which are much more specific and targeted to particular uses. This increases the flexibility of EC2 and allows you to pick the exact instance you need for your use. Since EC2 is such a critical piece of the AWS infrastructure, let's touch on a few more details. As far as operating system is concerned, you're able to use Linux, Windows, or Mac. You can also choose between ARM and x86 architectures, and as I mentioned, use instances that are either general purpose or specific to a workload optimized situation. AMIs, or Amazon Machine Images, are operating systems packaged along with software that you can deploy to an instance and quickly get it spun up. You have a couple options here. You can use public AMIs that are provided by AWS and available to any user, or you can create private AMIs in which you develop them and use them within your own accounts. You also have multiple purchase options, including on-demand, which allows you to dynamically increase or decrease the number of instances you have depending on the demand load for your service. You can do something called spot instances, which are priced based on the supply and demand of currently available instances. Typically, these are significantly cheaper and provide general cost savings. You also have the ability to make more long-term planning using reserved instances and or savings plans. And finally, for those of you who need actual isolated physical devices that you control, you can use dedicated hosts. The primary focus of the workshop will be AWS IoT SiteWise. AWS IoT SiteWise collects data from the plant floor with a local edge device. It structures and labels that data and generates real-time KPIs or key performance indicators and metrics to make better data-driven decisions. This system involves a few steps. It allows us to take sensor data from the production floor and ingest that in near real time into the AWS cloud. We're also able to structure that data and compute performance metrics upon that data so we make better informed decisions. Additionally, we can create and share dashboards that visualize this data throughout your company. And most importantly, is that we're still able to process this data locally and visualize it locally, depending on our connectivity to the AWS cloud. The ability to function locally is going to provide some additional benefits that we'll talk about going forward. We'll also be touching on a few of these particular features of AWS IoT SiteWise, including SiteWise Edge, which is an on-premise software that allows you to collect, organize, process, and monitor equipment data. With this, you're able to compute metrics and transform locally in the Edge gateway. You're also able to query properties and metrics from the data in the gateway for local applications, visualize data in real time through monitor web applications, and manage and troubleshoot gateways locally. The benefit of all of these features is that the services that you may rely upon in the cloud are available locally if and when internet connectivity becomes intermittent. It means that if you lose connectivity to the cloud, your production facility is not going to be impacted. AWS IoT SiteWise Monitor is the service that's going to allow us to create those visualizations. We can set up and deploy web applications for visibility into industrial machine and data within minutes without writing any code. You also have the ability to automatically discover and add context to these visualizations and receive alerts based on thresholds set up in SiteWise. And most importantly, you control who has access to this data and share it throughout your company. Now that we've introduced all the services that will come up during this workshop, let's set the stage for the actual use case that we'll be creating a solution for. In this case, the solution is to help a production facility monitor their industrial equipment. We'll be monitoring a drill press, which is an industrial piece of equipment used for boring holes in material. We'll be monitoring a number of its data inputs: the pressure of the actual spindle pushing down on the material, the speed of the spindle, the speed of the motor, and the state of the spindle, whether either it's spinning or not spinning, or in this case, the state of the drill itself as being on or off. We want this data to be available in two scenarios. We want it to be available to the equipment user on the production floor, and we want this data to be available to management who might be located off-site. So when we visualize this data, we need to be able to visualize it locally, and we need to be able to visualize it in a cloud dashboard. And what's important is that we need this to function locally, even if we don't have constant connectivity with the cloud. With that in mind, I'm going to drop off camera now so we have a little more real estate on our screen, and we'll begin walking through our workshop. Welcome to the AWS Industrial SiteWise Edge Workshop. Throughout this workshop, we'll be interacting with a fictitious piece of industrial equipment that resides on the shop floor. This piece of equipment will be a drill press. That drill press is going to be controlled by a PLC, or a programmable logic controller. We need to be able to give equipment operators on the floor access to the data from this PLC in real time and be able to access data dashboards locally and give management the opportunity to access these dashboards remotely and interact with it in the AWS cloud. So we'll be going through a number of different steps to allow us to gain some of this functionality and exploring as we go. As I mentioned during the introduction slides, AWS SiteWise is a managed service that lets you collect, model, and analyze and visualize data from industrial equipment at scale. We'll be using this in collaboration with AWS IIoT SiteWise Edge, which allows us to collect, organize, process, and monitor data locally in the field, as well as AWS IoT SiteWise Monitor, which will allow us to build a number of dashboards, both visibly locally and in the cloud. This page provides an overview of the workshop and what we'll be doing as we progress through it. If we look under the covered topics and learning goals, we'll see that we will be deploying AWS IoT Greengrass onto an edge gateway using AWS Systems Manager. We will then configure AWS IoT Greengrass to connect to OPC UA server and ingest data. We'll be building an asset model of a drill press in AWS IoT SiteWise, and we'll be creating near real-time edge dashboard in AWS IoT SiteWise to visualize the drill press operational data. And finally, we'll be creating a cloud dashboard to visualize aggregated drill press operational data. If we look at the architecture here, we can see how this workshop will be set up. You can see on the box on the left, we have the factory. Within it, we have our asset. The asset will be our drill press in this case, controlled by a PLC, or a programmable logic controller. It will be communicating via OPC UA, which is Open Platform Communications Unified Architecture. It's a communication protocol that is often used between automated industrial equipment. This OPC UA communication will be communicating from the PLC to the edge device that we'll be creating in IoT SiteWise. In this edge device, we will be installing AWS IoT Greengrass and AWS IoT SiteWise Edge. From here, we'll be able to create AWS IoT SiteWise monitor dashboards that local users will be able to access. Then if we look on the box on the right, we have the AWS Cloud. In the AWS Cloud, we'll be using AWS IoT SiteWise to create a cloud dashboard that management will be able to access remotely. And we'll be using AWS Systems Manager to access the EC2 instance where our edge device will be simulated. This workshop was created with operational technologists in mind and IT developers. So for those of you who are working with this, the expectation is that you have some understanding of working in a manufacturing industrial environment, and you have a basic knowledge of cloud, and you're wanting to learn to start building industrial applications. There's no particularly required background, but if you have knowledge of operational technology and industrial terminology, that would be beneficial, as well as basic experience using the AWS console. The expected duration of this workshop is roughly 2 hours. This video may or may not take that long. Participants in this workshop should have a personal laptop or computer that they are able to run this workshop on. iPads and similar tablet devices are not sufficient for the activity we'll be doing today. And costs. If you're running this in the AWS provided accounts, there will be no costs incurred on your end. If you are running this on your own AWS accounts, do realize that some of the resources we are using do incur cost, but if you're using it for a short amount of time, the expected cost is less than $1 US. In general, to avoid unnecessary charges, we would like to remind you up front that you should remove any resources that you create and terminate them completely once you're done with the workshop. And there are steps in this workshop to walk you through how to do that. Next, let's discuss the environment that is set up to run this workshop. There are 2 choices for running through this workshop. One will be on your own account, or 2 would be in an AWS sanctioned event where a temporary account is supplied for you. In either case, it will be run in one of the following regions: US East 1, US West 2, EU Central 1, EU West 1, AP Southeast 2, or AP Northeast 1. It has already been tested in all of these regions and is found to be functional. Here we can see an architecture of the scenario that will be created. Again, we see the largest box is the AWS Cloud, and within it we'll be creating a VPC, so we'll have a secure network that's dedicated to our workshop. Then we'll have a private subnet containing an EC2 instance running and simulating the PLC, or programmable logic controller, and then in a public subnet, an EC2 instance where we will be deploying our edge gateway. And also within the AWS Cloud itself, we'll be taking advantage of AWS Systems Manager to access and perform functions and commands on the EC2 instance. In this next architecture, we again see the AWS Cloud and our VPC. And we have an idea here of how we're going to also interact with AWS IT SiteWise and Amazon S3, where we'll be storing our equipment data as it comes in. As I mentioned, there are two ways to access the environment. One is if we're running this in your own account. In that case, you will be following step one here and launching a CloudFormation template within your account. The instructions here are supplied for you, but you need to navigate to the CloudFormation, and you can take this template after downloading it and deploy it. You can then follow these instructions to configure the stack. Specify a stack name, specifically AWS IIoT Edge Workshop. The remaining choices can be left to their default. And then go ahead and create that stack. And that's going to provide you with a number of the initial infrastructure resources required for this workshop. Now, if you're running this in a workshop provided by AWS, there's a pre-provisioned set of resources in your account. And I'll be walking through how to access your account on the next screen. To access the account that AWS has supplied for you for this workshop, you will be given a one-click join link. I already have that copied to my clipboard. I'm going to move over to a new screen now, and new browser, and enter that. So here we've pasted the one-click link, and at the end you see there's an access code. You may also access this via the join webpage using this access code. So I'm going to go ahead and navigate to the one-click link. You can see here we have the choice to sign in using an email one-time password. That's the choice we're going to take. For this, please do supply a functional password because it will be required that you acknowledge the email you receive. Now I'm checking my email off screen and I'm getting a one-time password. I've received the verification password in the email and I can paste it back in and sign in. We can see now that I can review and join the event. There's some information, some terms and conditions that you need to read through and acknowledge. After doing that, you're able to join the event. So now you have access to the event account and the event information. As you can see here, the navigation on the left is the same actual workshop content that I started showing you earlier. And on the bottom left here, we have some additional information for you. This is where you can open the AWS console and say you can get AWS CLI credentials. So for most of this, we're going to be using the AWS console. So we go ahead and click into that. It's going to open a tab. And we now have access to the AWS console. As you can see that we're taking on a user role of the workshop participant role. You also see that a few things are access denied. And that's because by design, the workshop accounts don't have access to everything, but they do provide access to everything you'll need for this workshop. Moving back to the workshop instructions, we can now advance forward and begin the actual workshop. First thing we need to do is perform the Edge Gateway installation. This we're going to be doing using AWS Systems Manager, and we're going to install AWS IIoT Greengrass. Before we can do this, we need to find one piece of information that was generated for us through CloudFormation. The piece of information we need to find is the PLC private IP. This is going to be found in the output section of CloudFormation for the template that we just created, or that was created for us by Workshop Studio. So let's move over to our console, and we're going to navigate to CloudFormation. The easiest way to do that is to go ahead and type it into the search and navigate to CloudFormation. From here, we can see that a stack has been created for us, and that's the AWS IIoT Edge Workshop. For the remainder of this workshop, I'm going to act as though you are in an AWS event, that everything has been pre-provisioned for you. But know that if you're doing this on your own, all the steps are going to be the same. It's just that you'll have had to do this first step where you actually provision this template yourself. So as I said, the template has been provisioned for us. We can access it, and we're looking in the output section. The output sections of a template shows us the resources that are actually created by that template. And we're looking for the PLC private IP. We have it here. This is going to tell us the IP address of the instance that is acting as our PLC. So I'm going to go ahead and copy that, and I'm going to save it to a notepad so we have it for later. With that taken care of, we'll jump back to the instructions and we'll move through. Throughout this workshop, you'll see that there are a lot of written instructions followed by screenshots that are going to show you the same thing. And then I'm going to talk through it on the video. So you have 3 different ways to reference and confirm that you're doing the correct thing. Next, we'll be using AWS Systems Manager, which will allow us to access our EC2 instance that is functioning as our edge gateway. So here we see some instructions. It's going to tell us how to get to AWS Systems Manager, how to start a session, and then some commands to run. Before I jump over there, let's just talk through a few of these commands. First thing we're going to do is we're going to run the sudo su ubuntu command to give us access inside the terminal. And then we're going to run the OPC UA commander command. This is going to allow us to actually connect to OPC UA commander running on PLC at that private PLC IP address. When that's happened, we're going to make a connection and we'll actually see the data coming from that PLC as well as the live telemetry from our drill press. We'll be seeing that here. And then once we've verified that we have this connection and we have access to the telemetry, we'll go ahead and terminate our sessions manager. So we jump back over. First thing we're going to do is we're going to navigate to Systems Manager. Here we are at the AWS Systems Manager console. And what we're going to be first using it for today is running Sessions Manager. So you can find that on the left navigation menu. Click on it. And we're going to start a session. We don't need to provide a reason this time, but we do need to come down and select our target instance. So we have 2 instances running in our account currently, the PLC server and the Edge Gateway. Right now we want to connect to the Edge Gateway. And we will start session. So now we're securely connecting to our EC2 instance that's going to act as our Edge Gateway. And we have access to its terminal. We now want to make sure we run the correct commands here. So I'm just going to copy these. And the second command, the OPC commander, will require our IP address that we noted earlier. And that is 10.0.100.241. With that in place, you can hit enter. You can use the arrow keys to navigate through the address space we see on the top left. Currently I'm in the root folder, so if I press down, if I press right, it's going to open it up, and down I can move down into it. So check out the objects, and we'll check out PLC, the main, and our drill. And then within the drill, we have each of our different measurements that are coming in, different telemetry, and we want to see those in the monitor items. We can highlight it and press M. So drill state. Drill state tells us whether or not the drill is working. The motor speed tells us the speed of the motor. The pressure tells us the pressure on the spindle pushing down. And the spindle speed tells us the speed of the spindle. So we can see here that we are getting live telemetry. We know that our PLC is functioning, or in this case, our simulated drill press is running and functional, and we have access to that data from our Edge Gateway. At this point, it's not an Edge Gateway yet. All it is an EC2 instance that is accessing information coming from the PLC. Our next steps will be to install IIoT Greengrass. So now that we've confirmed this, we can go ahead and terminate this terminal and move back to our instruction set. and advance to the next page. Our next step will be installing AWS IIoT Greengrass. By completing this section of the workshop, you'll see how you can use AWS Systems Manager to remotely manage and deploy software to edge gateways in your factory. So we'll be using AWS Systems Manager, and we'll be using the Documents option in order to push this Greengrass install to the device. So we're going to go to the documents, find those that are owned by me. We'll click on the Install Greengrass version 2, and we'll check out the content. Here we can see that this content that we'll be using sets up the parameters for the install. Specifically, it's going to name this device the IIoT GW-01 core device. Its default region was set up as US West 2, but you'll see that when we actually perform this, we'll be updating it to our current region. And it'll create a group as well called the IIoT-GW-01 group. The next thing we're doing is using the run command. It will execute this following script. And it's going to automate the install of a few necessary prerequisites and then the actual Greengrass installer as well. We'll need to manually choose the target, so we'll indicate which instance we want to perform this on. Again, this will be the edge gateway. And we want to choose where that data outputs from this gateway are going to land. And then finally, we will press run. So let's move over to our console and start beginning this. So here we are again in AWS Systems Manager. We're going to go to the documents on the very bottom of the left menu. In the top tabs here, we want to choose those owned by me. And we want to go to the Install Greengrass version 2. If we go into the content, this is the same things we just saw in the instruction set. And what we want to do is we want to run the command. We're going to leave some of this at the defaults. So core name, in general, you could choose to name this something else, but for the workshop purposes, keeping the naming conventions similar will allow everything to work downstream. Also, as I mentioned, the region here is going to be manually updated to our current region. For this workshop, we're working in US East 1, so this device will be created in the US East 1 region. And the group name was also mentioned in the parameters. Under the target selection, we want to choose instances manually. And again, we want to choose that edge gateway. For the output options, we're going to enable an S3 bucket, and we want to choose an S3 bucket from the list. This bucket will have been created for you by CloudFormation. So it should have a similar name, IIoT Workshop US East 1, and then your account number. And we want to enable CloudWatch logs. This is going to allow us to take the logs from Greengrass on the device and push them to the AWS cloud and be able to access them in CloudWatch. We will not be setting any alarms or SNS notifications at this time. We're going to go ahead and run the command. Here we can see that the command was sent and the status is in process. In a few minutes, we'll see that this status is completed, and then we'll be able to move forward. One thing to note while we're waiting for this update in status is that AWS Systems Manager allows you to remotely and securely manage the configuration of your managed nodes. So that's its intent. And what we've been using here is the run command, which allows you to automate common administrative tasks and perform one-time configuration changes at scale. So these are a couple of tools that will help you automate and scale your overall account management. It's been a minute or so, so I'm going to go ahead and try to refresh this. And now we see that our detailed status says success. So we're able to move on to the next step. To do so, let's move back to our instructions. Next, we're going to verify the install. We'll be doing this again via Systems Manager, and this time we're going to run a systemctl status Greengrass command. And what that does is that's going to provide us the status of the Greengrass install. And we'll be looking for some sort of similar output we have here, especially this green part that says active and running. After we confirm the Greengrass install, we'll be moving to the IoT Greengrass console in the AWS Management Console. We'll be accessing our core device, and we'll be configuring that in our following steps. So let's take a look. Once again, Systems Manager. We will use Sessions Manager to access. Again, starting a session, picking our Edge Gateway, start the session. While that's spinning up, we'll jump back and grab this command. And we'll go ahead and paste that command in. Immediately we see that the Greengrass service is active and running, which is successful. Once we've confirmed that it's successful, we can once again terminate the session. Now we'll be searching for Greengrass. IoT Greengrass will come up. And we're ready to check in our core devices. Here we can see we have our IoT gateway device, and it's healthy. Let's look back at our instructions to see what's next. In the next section, we'll be configuring our AWS IoT Greengrass installation on our Edge Gateway. We'll begin by going to the AWS IoT Greengrass console, clicking on our core device, and going to Deployments. Deployments allow us to target a thing or a thing group and allow us to configure the software components that are deployed and how their deployment job rolls out on each of these target devices. You can define these deployments through JSON files, which we'll see momentarily. We'll also see that as we move into this, there are both public and private components. So if we click on the Components tab on our device, we'll then be able to see which components are involved. From there, we can choose the public or private components. Public components are those provided by AWS and available to all users. Private components are bits of software that you have created for your Greengrass solutions that are only available to you. For the workshop, we're going to be selecting the aws.greengrass.log manager and aws.greengrass.nucleus components. The Nucleus component is a mandatory component and the minimum requirement to run AWS IoT Greengrass core software on a device. You can configure this component to customize and update your AWS IoT Greengrass core software remotely. You should deploy this component to configure settings such as proxy device role and AWS IoT thing configuration on your core devices. The Log Manager component allows us to upload logs from AWS IoT Greengrass core devices onto AWS CloudWatch logs. We'll then be moving forward with our components, and we'll be actually configuring the aws.greengrass.log manager component. We can see here that we're using this JSON, which is going to basically set the parameters for our log management component. As you can see, it's going to allow us to upload to CloudWatch, and the minimum log level is going to be info. And then it has a space limit for the logs stored locally on the disk. In this case, 10 megabytes. If there were more logs than that stored locally, it would start to delete the oldest logs and overwrite them with the newest logs. And in this case, we do not want to delete the log files after they've been uploaded to the cloud. We'll then advance to the next screen and deploy. And again, we have screenshots here of this same execution. So let's jump over to our console. So here we are in the Greengrass console, and we have our core device, the IIoT gateway. We're going to go into it. We're going to select deployments. And we can see that we have a currently successful deployment. That's from our previous deployment we sent in. If we go back to components, we can see that we have a couple of components here. We have the AWS Greengrass Nucleus and AWS Greengrass CLI. From the deployment screen, we can choose our deployment, choose the name here from before. And now we can see our previous deployment status is active, and we are going to revise that deployment. This is going to allow us to make an update to the device. We can go ahead and keep the deployment information the same. We're targeting the correct core device. Here's where we can actually pick our components. So currently it's showing only selected components. We want to show everything temporarily. We want to bring up the aws.greengrass.nucleus. Select that one, clear, and bring up AWS Logger. So search for log. We got AWS Greengrass Log Manager. Now we can go ahead and clear this and show only the 3 that we have selected. At this point, we can hit next. And we want to update the configuration for our log manager. So we're going to select that one and hit configure component. This is where we can make updates to the component itself. So we need the JSON file from our instruction set. So we go ahead and copy that. Come back here, and inside the configuration to update and configuration to merge, we're going to paste that JSON. Confirm and hit next. These are all optional settings, which we're not going to be touching on today. You'll be able to review your selections and deploy. Here we see the deployment is successfully created and the deployment status is active. If we jump over to our core devices, we can see that our device is healthy, and we can see right now that there are some components that are running but not finished. If we refresh, we can see that our Nucleus, our CLI, and Log Manager are now either all finished or running. And if we check deployments, we can see that our most recent deployment has succeeded. Now we're able to go on to the next step. The last set of instructions for this page is to go to CloudWatch. So we're going to go ahead and navigate there now. Here we are in CloudWatch, and as we mentioned in the introduction, CloudWatch is a service that allows us to monitor the activity within our account. So we're going to go to our log groups on the left menu, and we're going to pick the log group that says install Greengrass v2. We go down to the log streams, we're going to pick the most recent one, and we can see that we're getting active logging from our Greengrass device in the AWS cloud. And that confirms that the Greengrass logger component is now functioning correctly. So with that in mind, we'll jump back to our instructions and see what's next. The next step will be updating our Edge Gateway permissions. Now that the Greengrass has been deployed on the Edge Gateway, we need to add an additional permission to allow it to send data to AWS IoT SiteWise with IAM. Our next step will be to add additional permissions to our Edge Gateway. From the AWS console, we're going to select IAM, or Identity and Access Management, from the Services menu. We're then going to go to Policies and create a new policy. An IAM policy is an object in AWS that, when associated with an identity or a resource, defines their permissions and the actions they're able to take with it. You can see here the first policy that we're going to create. In this case, it's going to allow all resources the action of using IoT SiteWise batch put asset property value, which allows resources to send property values to IoT SiteWise. We're then going to create a second policy, which we see here. In this case, it'll be an inline policy applied specifically to a particular role. Again, we can see the actions that are now allowed. A number of these involve IoT SiteWise, logging, and S3. So we'll move over to console and begin making those updates. To To do so, we're going to navigate to IAM. And we're going to access the policies. And we're going to create a new policy. In this case, you have two choices when you're creating a policy. You can do it through the visual creator or the JSON. Because we have the JSON supplied to us, we're going to use the JSON in this case. I've already copied it from our directions, and I'm going to paste it here in place of the default. We can see this is the policy we looked at previously. And we're going to hit next. And we want to give it a name. And the name we want to give it comes from the instructions. That's going to be the Greengrass v2 SiteWise Edge policy. Description is optional. We go down and hit create policy. We get the green notification that the policy has been created. And the next thing we need to do is refer to the instructions. We're going to find a role. The role we're looking for is the Greengrass v2 token exchange role. So we're going to go to roles and search for green. And then we're going to be attaching a policy, an inline policy, with this JSON here. So I'm going to go ahead and copy this JSON. Return to the console. Go to our roles. Search for green. Found the Greengrass v2 token exchange role. While we're here, I should point out that IAM roles are IAM identities that you can create within your account to give specific permissions. An IAM role is similar to an IAM user in that it has AWS identity with permission policies that determine what the identity can and cannot do. However, instead of being uniquely associated with one person, a role is intended to be assumable by anyone or any resource that needs it. This role that we're acting with now, this Greengrass v2 token exchange role, is used to authorize core devices to interact with AWS services. Now we'll come down to add permissions, and we're going to attach a policy, the policy that we just created. So if we search for green again, we should see the Greengrass v2 SiteWise Edge policy that we created. Go ahead and select that. And we know that it's been attached to this role here. And if we wanted to confirm, we could go ahead and hit the plus and see that same policy we saw previously. The next thing we'll be doing is adding an inline policy with the JSON that we just copied from the instruction set. Here we have the additional actions that are now allowed by this role. Again, we need to give it a name. This one we're going to call the Greengrass v2 SiteWise Edge Inline Policy. And create policy. We've now created the additional permissions and applied them to the policy or to the role, which will allow our core device to interact with AWS services. In the next section, we'll be modeling the assets. We'll be configuring the connector to communicate with the OPC UA server and build the asset model in the AWS IoT SiteWise. Next, we'll be navigating to IoT SiteWise and clicking on Edge Gateways. From there, we're going to create a new Edge Gateway. But that's going to involve giving it a name, defining the device that it's attached to, turning on Data Processing Pack, which enables SiteWise Edge Gateway to communicate with Edge configured asset models and assets. You can use Edge configuration to control what asset data to compute and process on site. This is going to give us some additional options working at the edge going forward. We'll then create the gateway and begin some additional configuration steps. Before we get there, let's create the gateway first. So we'll be navigating to IoT SiteWise. And from the left menu, we're going to Edge Gateways. Go ahead and close these notifications and create gateway. The gateway name we're going to be using is Edge Gateway 0, 1. Go ahead and copy that. The device OS is already set as needed. We're going to turn on the Edge Capability Data Processing Pack. Go to the Advanced Consideration and the Advanced Setup. And we're going to choose our core device, which we created previously. If you hadn't already created a core device, you could also create one now. We here get the success banner, and we can see that our gateway has been configured, but it's currently disconnected. And that's because there's a few configuration steps we still have to take care of. Let's jump back to our instructions and see what they are. We can see the first configuration step is an optional step involving LDAP, or Lightweight Directory Access Protocol, which is a protocol used for accessing and maintaining distributed directory information services over a network. For the purpose of this workshop, we're not going to be implementing this, but know that these instructions exist here if it applies to your situation. The next thing we're going to do is we're going to add the data sources. This is where we're actually going to be able to connect to the data source coming from that PLC and provide that streaming measurement data to our Edge gateway. To do so, we'll select OPC UA from the dropdown and provide a name for the device. In this case, we're going to name it Drill PLC and provide this local endpoint. So we'll go ahead and copy this piece because we'll be needing it later. Under the advanced configuration, we want to make sure that the activate data stream prefix optional setting is currently off. This is a setting that allows you to better organize your data streams, but isn't necessary for the workshop that we're doing today. Also, for future reference, if your OPC UA server had authentication or security enabled for the connections, then you would configure this under the advanced configuration settings as well. Under the Edge Capability section, we'll be checking on each of our software versions and make sure that our components are up to date. And if not, we'll be deploying the most up-to-date version. The last thing we'll be doing to make sure that we can sync our Edge gateway is updating the publisher configuration. We'll be leaving out all of its defaults, but the publisher configuration is the area where we're able to determine if we lose connectivity with the device in the cloud and that device is storing data locally, which data points should be sent to the cloud first, the most recent or the oldest. For our use case today, we'll be maintaining the defaults, but we'll take a look at it anyways and make sure it's updated. Then after a few minutes, we should see that the device or the Edge gateway is all in sync and ready to move on. So let's move to the console and begin some of our updates. So the first thing we want to do is our data sources. Let's go ahead and add a data source. And OPC UA is already chosen for us as the source type. For the source name, we want to use Drill PLC. And for our endpoint, paste this in. And we need to use our private PLC IP again, which is 10.0.100. And we're going to check this advanced configuration, and we want the activate data stream prefix off. You can see that if we turn it on, this is where we can actually create some prefixes to help us organize our data streams, but we'll be leaving it off for this workshop. Okay, we can see the updates are taking place. Next, we're going to check our Edge capabilities and make sure that our software versions are up to date. So if we go to View Software Versions, we can see that we have these versions deployed. To check and see if they're the most current, go ahead and click on it. We can see that 2.42 is the most current, 3.13 is the most current, and 3.2.1 is also the most current. So in this case, we don't need to update any. The last thing we may want to do is go to the publisher configuration and edit that. And as I mentioned, this is where you can set whether or not to publish old data first or new data first. We're going to leave at the old data and hit save. At this point, we would expect that the gateway has connectivity. The edge capabilities are activated, except for LDAP, which we're not using today. Publisher configuration is in sync, and our data sources are in sync. If that's all true, then we can go back to our instructions and see what's next. In the next section, we'll be creating our models. An asset model is effectively the schema of an asset. So it defines the type of an item. In this case, a drill press, but in general, it represents a device or a piece of equipment or a process that uploads one or more data streams to the AWS cloud. So I mentioned we'll be creating a drill press, and that drill press is going to send drill state, spindle speed, motor speed, and pressure. So we're going to begin by creating a model of this drill press, and then we'll be creating a specific instance of that model. So as you can see, we're going to go to the SiteWise console, go to models and create a new model, give it a name and a description, and then we'll define its attributes. The attributes are the characteristics that are true of this model type, or this asset type. So in this case, we'll have location and asset number. Next, we'll define the measurements that are part of this model. As I mentioned, there will be pressure, motor speed, spindle speed, and status. We'll then create metrics. Metrics allow us to perform computation on the measurements, so we have more aggregated information, things like averages. In our case, we'll be creating an average pressure, an average spindle speed, and an average motor speed. If we move over to the console, we can begin. So we're in SiteWise, we're going to go to Models, clear these banners, and create an asset model. We're going to go ahead and name the model a drill. And our description is a drill press. This is an optional field. And we're going to define some of the attributes. First one we're going to use is location. And we want to make sure that's a string type so we can actually enter in the location. The second one we're going to do is asset number. And it's also going to be a data type of string. Then we can go ahead and create this model. But it requires a default. So in this case, we're going to use the default value as default. We've now successfully created the drill model. Now, if we go into edit it, we can then update the measurements and the metrics. This time, under the definitions, we'll go to our measurements tab, and we're going to add new measurement. First one we're going to add is pressure. We want to define its unit as bar, and we want to leave the data type as double. Next, we're going to do motor speed, and define its unit as RPM, and leave it as double. We have then spindle speed, again RPM and double. And then finally status. And the unit in this case is going to be status, and it's going to be a string. The final thing we're going to do is update our metrics. The first thing we want to create here is an average pressure. So we're going to create a metric called average pressure, and we're going to write the formula. We do AVG and open parenthesis. It's going to allow us to then select our variable, which is pressure, and complete it. We want to use a 1 minute time interval and no offsets. So we go ahead and add another metric. In this case, we want average spindle speed, and do something similar here. AVG, open parenthesis, spindle speed. We do not need a custom time interval, so I can close that. And we'll add one more. Last one being average motor speed. was created, we can go down and save the changes. And we can see that we have successfully updated the model. If we return to our instructions, we can see that we have created the measurements, we have created the metrics, and we are ready to go on to the next step. In this step, we actually be creating our asset, which will be our drill press. And this is going to be an instance of the asset model we created. To do that, again, we'll be on AWS IoT SiteWise console. We're going to go to Assets, we'll go to Create Asset. We're going to provide our asset with the model identifier, in this case drill, and we're going to provide a name, drill01. We'll create that asset, and then by editing the asset, we can update its attributes, its asset number, and its location. So we want this first asset to be located at plant 01 and asset number 0001. So here we go to our asset section under IoT SiteWise, and we're going to create our asset. This is where we can define the model we're using, which is drill, give it a name, which is drill01, and create asset. We see we've successfully created it. We want to go ahead and edit it. Now we can update those attributes. So our location is going to be plant 1, and our asset number is 0001. We can go ahead and save those changes. Now we have an asset that is defined based on our model and attributes that are specific to it. After creating our asset, we're going to connect the data streams. And what this means is we're going to actually map that incoming telemetry data from the drill press on the floor to the asset and its measurements. So we're going to open up data streams, and we're going to look for these data streams that should be familiar: pressure, motor speed, spindle speed, and drill state. And we're going to proceed to manage these data streams. And then we're going to map them to the measurements of our asset. Once they're completely mapped, we will update, and we actually should be able to see incoming live telemetry data. So if we open up the asset, after we map this data, we should be able to see in the Measurements tab under the latest value a frequently updating value coming in from our drill press. So let's click on Data Streams, once again in IoT SiteWise. And we can see here we have a number of data streams coming in. So we want to select the spindle speed, pressure, motor speed, and drill state. And manage data streams. In this case, we need to select our asset name, which is drill. And then we want to map each one of these. So the first one, we'll start with pressure. And we want to choose the one that matches, which is going to be the pressure data stream. Next, we'll do the motor speed. Choose. We'll do the spindle speed. And finally, status. And now we can see that they've all been mapped, and we can update. Now under our data streams, we can see that the asset property names have been mapped to the data stream aliases. And if we return to our assets, we can check out our drill01 under measurements. If we scroll over, we can see we have some latest values coming from the telemetry. And if we give this a second, we should see that they are updating. There it is, there's a change. So we have active telemetry coming in, and it's being mapped correctly to our asset measurements. Now that our asset is created and our data streams are connected, we're able to move on to the building of the dashboards. In this chapter, you will build two dashboards in AWS IoT SiteWise Monitor. The Edge dashboard is to view the drill press telemetry you configured in the asset model in the previous chapter, and the cloud dashboard is to view aggregated measurements, which are metrics and transformations. Edge processing reduces the amount of data that needs to be sent to the cloud, which can help to reduce costs and improve performance. So moving forward, we're going to work through how to actually create these dashboards through AWS IoT SiteWise Monitor. We'll begin by creating the Edge portal. So you can see here, we'll be going to SiteWise, Monitor, and under Portals, we're going to create a new portal. We'll be providing it with a name and an optional description. Then we'll have to decide how to authenticate. In this case, we'll be authenticating using IAM. We'll then need to provide permissions to the correct role and user to access and administer this dashboard and portal. Once we have the portal created, we're actually going to create the Edge dashboard. In doing so, we'll move to the Asset section and we'll connect to our Drill 01 asset. We'll then assign owners to the project and make sure that the workshop participant role and workshop control plane user have access and are able to administer this project. From there, we'll create the drill press Edge dashboard. By doing so, this is a very intuitive system. It allows you to drag and drop different measurements from your drill asset. You can see that we're going to be placing the pressure telemetry on one graph and the spindle and motor speed telemetry on a second graph. We'll then click to save the dashboard and we'll have the first of our dashboards completed. Here we are once again in IoT SiteWise. In this case, we're going to go to Monitor and Portals, and we're going to create a portal. Let's jump back to instructions and make sure that we get our naming conventions correct. We're going to name this first one the Drill Press Dashboard. And for authentication, we're going to choose IAM. This is why we need access to an active email. In this case, I need to put in my email. And then we'll proceed to the next. We're not going to activate any alarms. The last thing we're going to do is activate this portal at the edge. Turning this on will make the portal available on all AWS IoT SiteWise Edge gateways with data processing pack activated in your account. It says we have successfully created the portal. I'm going to copy that URL and paste it to my notepad for future use. And jump back to our instructions. Now that the portal is created, we need to assign permissions to access it. We can do that by clicking on the Roles tab, and then we're going to select the workshop participant role and the workshop control plane user. So we start with the roles. If we just type in WSP, we should get the workshop participant role, and we can hit. We want to add them as an administrator as well. Hit next. So it asks us for users. In this case, we want the workshop control plane user for both the IAM user and portal user. And we'll assign the users. And as you can see, we have successfully added users. I'm going to clear some of these announcements out. Now that we've created the portal and established who has access, we can actually open this portal. So we click into it. We can then press Open Portal. Here we are inside the Drill Press dashboard, or Drill Press portal. We can go ahead and close the welcome window and access our asset. We want to add an asset to the project. We've already selected the Drill 01, and we just select it here and hit Next. Once again, to make sure that we are naming this correctly, let's jump to our next instruction. We want this to be the drill press edge dashboard. In this case, a description is required, so I'm just going to go ahead and paste that there as well. Okay, we have now created the drill press edge dashboard. And if we want to create this dashboard, again, let's confirm that we're naming this correctly. We want to name this the drill press edge dashboard. You can name that by just updating this here. And then we can begin to create our dashboard. First thing we're going to do is we're going to drag our pressure on, and we can resize it so that it fits the full width of the screen. We can see that we're getting data values are coming in, telemetry is coming in. Next, we want to grab our spindle speed and do something similar. And we'll resize it. And for this one, we're also going to add motor speed to the same chart so you can see them, visualize them together. So as that writes out, we should see a second line show up. There it is. And we have live telemetry coming in. I'm going to go ahead and hit Save Dashboard. And now we have a drill press edge dashboard that's available to the users or the actual equipment operators on the floor that have access to the edge gateway. One thing I want to update here before we move forward, if I go back to the drill press edge dashboard, I need to update the project owners and project viewers. So I want to go ahead and make the participant role and control plane user project owners. And with that, we're going to jump back to our instructions to see what's next. So we've created our dashboard, made sure that our owners are updated. After creating the edge dashboard, there's a few more steps we need to take to make it accessible locally to a monitor that is then in communication with the edge gateway. This section has a number of steps involved, so I'm likely to step back and forth from the instructions to the console a little more frequently in this section. What we're going to be doing to access our dashboard is building out this URL, which is basically HTTPS public IP address of the edge gateway, portal, and then the portal ID. So we need to come up with the IPv4 address for the edge gateway and the portal ID. First thing we're going to do is go to EC2 and we'll access our actual instance for the edge gateway, and that's going to give us our public IPv4 address. Let's do that first. So we're going to go ahead and close this dashboard, and we're going to go to EC2. Now inside the EC2 dashboard, we can see that we have two instances running. One of those is our edge gateway. If we click onto that instance ID, we can see here the public IPv4 address is listed. I'm going to copy that and place it in our notes. Now that we have that, we can move on to the next step. Next, we need to add a policy that's going to allow our instance to get a list of AWS IoT SiteWise monitor portals. To do that, we're going to return to the IAM console. We're going to select roles, and we're going to find the edge gateway role. So let's copy that to search for. Once we find that role, we're going to add permissions and we're going to create an inline policy, similar to the way we did before. We're going to go ahead and grab this policy. And the last thing we'll need to do is name it. We're going to be naming it the SiteWise List Portals policy. We'll come back and grab that in a second. So we go to IAM. And we go to roles, searching for Edge Gateway role. And we want to add a permission via an inline policy. We're going to be using JSON again. This is what I described from the instruction set. We can hit next. Jump back to the instructions to grab the name, which is going to be SiteWise List Portals policy. And we're going to create policy. You see the policy has been created. Next, we're going to Sessions Manager once again to access our EC2 instance. And we're going to be running the following command. We should get an output similar to this. We're looking for an ID of the first one, and that's providing an ID of the portal that we created. So if we go to Systems Manager and Session Manager, as before, we're going to start a session on the Edge Gateway. Start session. Now I have access to the terminal. I'm going to go ahead and paste that command. And because we updated the permissions, we're able to receive and retrieve this information. And we see that we do have an ID. So we're going to go ahead and grab that and copy it to our notepad. Turning to the instructions, we're going to run some additional steps here. While we're still in our terminal window through Sessions Manager, we're going to add a new group using the sudo group add command. So let's copy that, paste it in. It was successful. We're now going to add in a user, and I want to update its password. So I'm going to go ahead and select this, paste it in, but don't hit enter yet because we need to replace the choose your password. And for simplicity, we're going to do 1, 2, 3, 4, 5, 6. This should go without saying, but in general, you should choose a difficult password when you are setting up your infrastructure. And just make sure I have this correct before we jump back there. Okay, and hit enter. Okay, we've added a new password for that user. Next, we want to do a sudo user mod. So we can copy this one, paste it in. Again, it's been accepted. We now have created a user suite admin in the suite admin group, and we're able to terminate our session. We need to do this because this is going to give us a user group and a username and password to actually access this portal via the URL we're creating. I'll terminate the session in just a second. Before we do that, there's one more step we need to do. We need to go to our EC2 dashboard once again and the security groups, and we need to give access to our specific IP address that we're working from. Because of this workshop, we need to give access to the device we're working from. In a real-world scenario where you're working on a production floor, you need to give the IP address of the particular device that you want to be able to access the portal, or a range of addresses that are specific to your internal network that should have access to this portal. So to do that, we're going to return to the terminal. We can go ahead and terminate. It'll be returned to the EC2. Oh, we're actually in Systems Manager. That's true. We need to return to EC2. And in this case, we're going to go to security groups. And we're going to find the security group called Edge Gateway Security Group. And we're going to change one thing. We're going to edit the inbound rules. And we're going to add a new rule that says if you have HTTPS as the type, and the source is my IP specifically, it will now allow the inbound traffic. It's been successfully updated, so we can return to our instructions. The last thing we need to do is actually assemble our URL. The easiest way to do this might be to copy this, move it to our notepad, and replace the parts. So our public IPv4 goes in the first section, and then our portal ID goes in the last section. And then once again, copy the whole thing. And we're going to return to our console and just open another tab. And enter. It's going to let us know that our connection is not private. That's part of our workshop setup. Go ahead and advance and proceed. Now we have our actual login, and we can see here our username. We're going to use suadmin, which is what we set up. Our password of 123456, and we are authenticating. We get the local user pool, and we'll sign in. Now we can see that we have access to the drill press dashboard. And here we have read-only access of the actual telemetry coming out. So this is how a user on the production floor can have a screen attached to the Edge gateway and be able to receive this live telemetry on the floor. The last thing we want to do this section is we want to go to our model and update our drill. We want to do that so we can compute all these properties at the edge. This allows us to save on data transfer to the cloud, and we'll be performing the actual computation of the metrics at the edge versus in the cloud. So we're going to go to our model and update our drill, and we're going to hit configure for edge. We want to choose the edge configuration for the asset model. We want to compute all properties at the edge. And we'll take note that for metrics, they're going to be now computed at the edge, and measurements will also be kept at the edge. After doing that, our gateway will now only send the aggregated metrics to the cloud, and it's going to compute all the metrics at the edge. By reducing the amount of data that we're transferring from the edge to the cloud, we make our solution more cost efficient, and then we're transferring less data, and more reliable in case of intermittent connectivity. We no longer have to transmit as much data to the cloud to still be able to function correctly. So again, we're going to close the dashboard, return to SiteWise, go to our model, click on drill. We're going to configure for edge. And we want to now compute all properties at the edge. And we can see this says keep everything at the edge now. And compute at the edge. And save. And once again, the model has been updated successfully. Next, we'll be creating the cloud portal. In this case, you'll be creating a cloud dashboard to monitor the aggregated measurements, or the metrics. This is useful in situations where there's limited or unreliable internet connectivity, or where sending large amounts of data to the cloud would be prohibitively expensive. Now this will look very similar to the previous portal we created, but the actual dashboard we're creating is going to be from the metrics versus the measurements. So it's going to be the averaged values coming through. So again, we're going to go to the monitor portals, create a portal, give it a name, provide authentication. Then we need to provide the permissions for who has access and who can administer the portal. And then we'll open the portal and actually create the dashboard. When we create the dashboard, it'll be very similar again. We're going to add the same asset and the same owners, provide a new name. But in this case, we're going to be bringing in the average motor speed, average spindle speed, and average pressure. These will come in as pre-calculated on the edge metrics. And then we'll save this dashboard. So if we go to monitor and portals, we're going to once again create a portal. The name of the second portal is Drill Press Cloud Dashboard. Again, we'll be using IAM. I need to provide an email address. And next, we want to activate the portal at the edge once again. We can close these alerts. And we'll set the roles. Role, again, we need the workshop participant role. And the portal admin is going to be the same. And then for users, it's going to be the workshop control plane user for both. The portal creation is now pending. We've successfully added users. And it's now successfully created the portal. So if we click into the cloud dashboard, we can see that it is active and we can open that portal. Again, we can close the welcome screen and go through similar steps to create the dashboard. So in this case, we want to add the drill. Go back and check the name we're going to be using for this one. Assets, and project name is going to be Drill Press Edge Dashboard. And again, this description is required, so we can duplicate that. Go down to our project owners and add the owners. Again, select both the participant role and the workshop control plane user. And now we can create the dashboard. Let's go back and check. We're going to use the name Drill Press Cloud Dashboard. And we're going to grab the average pressure property first, followed by the average spindle speed and average motor speed. So we can update the name. And then we want to grab the average pressure. Again, resize it. And do the same for average spindle speed. And average motor speed. Again, we can see we have live telemetry coming in. These are being calculated at the edge, and it's only sending up the actual aggregated values in this case. And finally, we will save our dashboard. This brings us to the end of the workshop. Throughout this workshop, we deployed AWS IoT Greengrass onto Edge Gateway using AWS Systems Manager. We configured AWS IoT Greengrass to connect to OPC UA server and ingest data. We built an asset model of a drill press in AWS IoT SiteWise, and we created a near real-time edge dashboard in AWS IoT SiteWise to visualize the drill press operational data. We also created a cloud dashboard to visualize the aggregated drill press operational data. There's a number of additional resources available here, which link you to AWS documentation. of different content that we covered throughout. Now, please, especially if you're doing this in your own account, before leaving, when you are done with these resources, please terminate them so you don't incur any unnecessary cost. If you're in an AWS provided account, you can go through this as a good exercise, but know that these resources will be terminated when the workshop event is complete. The following steps on the next page will give us instructions for cleaning up the resources we created throughout this workshop. The first thing we want to do is navigate to S3 and locate the bucket that was produced by the CloudFormation template. We need to empty that bucket and then delete the bucket. Next, we will go to the CloudFormation stack and we will delete the CloudFormation stack. In doing so, that will remove all of the remaining resources that were created by that template. So we return once again to the console. We can navigate to S3. And we can see the bucket that was created by the template. If we select the folder with its contents, we can hit delete and then type in permanently delete to confirm. We have now successfully deleted the objects, and if we return to the S3 bucket, we can go ahead and delete the bucket itself. Again, you need to confirm the delete. And S3 no longer has any buckets. The last step we need to do is return to CloudFormation. Select the template that we created and delete it. This may take a few moments, and we'll see the status has changed from create complete to successfully deleted. We can see that it has updated to delete in progress. We can also click into this to get a little more detail if we're interested. We can see the events and see it progressing. Again, we'll be looking here for the delete complete. Now we can see that the delete is complete. And we know that all of our resources created by that template have been terminated. So we've successfully removed all of the resources created for this workshop. Thank you for joining us for today's AWS IoT Edge Workshop video tutorial. Throughout, we touch on all of the AWS services that are covered in this workshop, including CloudFormation, which is used to develop infrastructure as code, AWS Systems Manager, which can automate account management, AWS IoT Greengrass, which is an open source edge runtime for IoT devices, AWS CloudWatch, which can be used for account monitoring, AWS IAM, or Identity and Access Management, and Amazon EC2, which is flexible cloud computing services. AWS IoT SiteWise was shown to collect and process industrial data. AWS IoT SiteWise Edge was used to monitor and organize edge devices. And AWS IoT SiteWise Monitor was used to build web applications and to visualize and share industrial data. We also had some hands-on exploration of AWS IoT SiteWise Edge Gateway creation and configuration, as well as AWS IoT SiteWise asset creation. We also mapped data streams to asset measurements, and we created both local and cloud dashboards through portal creation. If you'd like additional resources, please see the conclusions page of the workshop for links to other relevant AWS resources and documentation. Thank you again for joining us, and good luck with your own solution implementations.